Bismillahirrahmanirrahim. Good evening, everyone. Today, our lecture will focus on how we can calculate the dynamic current at ideal diode at mid injection, or we will start from this topic, but after that, let's do a simple review about how much kinds of resistance we have at non-ideal diode and with ideal diode. At non-ideal diode, we have two kinds of resistance: the series resistance and shunt parallel, or we can say RSH. The shunt and parallel, that's the same meaning. All of these two kinds belong to effect or parasitic resistance with non-ideal diode. And number two, at ideal diode, we have two kinds of resistance: statical, or we can say DC, and number two, dynamical, or we can say AC resistance. Now let's talk about at middle injection, how we can calculate the dynamic current at ideal diode. We will start from the diode current equals saturation current exponential diode constant V minus V at Rs. That's mean the different potential at series resistance minus 1. From Ohm law, V at Rs equals saturation current dot series resistance. At ideal diode, here we calculated the current at diode, but at non-ideal diode. But at ideal diode, we will put 0 instead of Rs, because that will be ID equal I naught exponential diode constant V minus 1, like that. That means we come back again to Schottky equation. Now let's work on the Kirchhoff voltage law. V total equal Vd, that's mean the diode potential plus VRS, that's mean the potential at the series resistance. We calculated the diode voltage equal 1 at the last lectures. 1 on the diode constant length I on I saturation current plus 1. We will put it here, and we know the VRS result equal saturation current dot series resistance will be like that, V total. Now, this V total at non-ideal diode, but at ideal diode, VRS will equal 0, because like we know at ideal diode series resistance equals 0. That means VT will equal just VD 1 on diode constant length I on I naught plus 1. At non-ideal diode, V total equal VD plus VRS from Ohm's law. Here Rs will not equal 0 anymore, and we have saturation current, because that VRS will has huge amount, huge result. By the way, we can ignore the Vd result to be V total equal just the series resistance voltage. Now let's work on at low bias saturation. At first, we was working on the middle. That's mean from V1 to V2 until here. This at middle, this curve. Now we will work at low injection. That's mean at this small region. At low bias saturation, here, like we know, like I said before, Vs, the source voltage, equal the Vd, the diode voltage, plus the different potential at the Rs resistance. Now let's work by, at first, we will focus on forward bias. That's mean very little saturation current equal picoampere from Kirchhoff voltage law. Summation voltage equal, like I said before, Vd plus VRS. We calculated Vd at the last lecture equal 1 divided on diode constant length I on I naught plus 1. and we know the result of VRS. But here, saturation current has very small amount, because that we can ignore it all the VRS value to be V equal Vd. At reverse bias, the situation will be different, because here the voltage at the series resistance will be huge comparison with the Vd, because that the V total will equal the voltage at series resistance at reverse bias, not forward bias. Now let's work on high injection. At first, we will start from voltage 1 until 2. After that, we was working on this small region. Now at last we're working on the after V2 point. At high injection to non-ideal diode, from Kirchhoff equation, Vd plus VRS, Vd very small, we can ignore it, Vt equal VRS. The same idea, the same way. Now let's work on at ideal diode. All these will be different, because at ideal diode we will dealing with linear, not with curve like the last situations. Here prove V enter equal V diode or diode voltage bias at ideal diode, and draw the diagram at high injection. Here I at x-axis, y-axis, V at x-axis. At the ideal diode, that non-ideal diode will be curved like that, and after that we will start to be something like behavior like Ohm's equation. Now we will start from the slope equal delta I2 minus I3 minus I2, and V2 minus or V3 minus V2. And we can say 1 divided on series resistance. Here low injection, middle injection, high injection. We will depend on this important equation, I equal slope dot V plus I intercept. Intercept, this point is intercept. This point is intercept. Something like cross point. Here I equal 0 at ideal diode, slope equal 1 divided on series resistance, V equal V intercept will be like that. Now V intercept equal minus intercept dot RS for high saturation. Now we must have the I-intercept result to can keep going. When V-intercept equal V threshold, the same meaning, but by using different word. Another source use V threshold. V enter equal V threshold, and V equal minus I intercept dot series resistance. Here, I intercept equal minus Vd divided on Rs, because that we will put this result here to be minus Vd on Rs dot Rs to equal, we have 2 minus, because that we can delete it or write positive, will be I intercept equal Vd. By the way, we can prove it. We could prove it. V intercept equal diode resistance. That's it. Our lecture is done. Thank you for watching. You're listening. Have a good day.